In this video, I will be teaching you how to rationalize the denominator. To rationalize the denominator, we first have to know that surds, or the root of any number n, where n is a positive integer and is not perfectly square, is considered to be irrational. And from this we can derive that rationalizing the denominator means that we want to get rid of any irrational numbers within the denominator. That is, we want to get rid of any surds in our denominator. So let's look at the example of the fraction 5 over the square root of 11. So what we want to do here is we want to rationalize the denominator. So the obvious question comes to mind: what sort of operation can we perform on this in order to rationalize our denominator? Well, we know that anything times 1 is equal to itself. So if you multiply this by 1, we get 5 over the square root of 11. And we also know that any number divided by itself is equal to 1. So if we have any number a divided by a, we get 1. So using these two concepts, we know that if we take our fraction 5 over the square root of 11 and multiply it by any number a over a, then we are not changing the value. So this is essentially still equal to 5 over the square root of 11. Now all we need to do now is determine what number a we need to use in order to rationalize our denominator. And we should also note that when we're rationalizing our denominator, we don't really care about whether or not the numerator becomes irrational. All we really care about is that in our final product, the denominator is not irrational. So anyway, we know that any root or any surd multiplied by itself, so the square root of a times the square root of a, is equal to the square root of a squared, which simply gives us a. So from this we can tell that all we need to do now is multiply the square root of 11 by itself to get a rational number. So that gives us our value for a, which we want to take. So we have 5 over the square root of 11. We multiply this by the square root of 11 divided by the square root of 11, which is essentially, or this equation, or this thing is equal to 1. And we get 5 times the square root of 11, and the square root of 11 multiplied by itself gives us 11. And now we have a rational denominator, meaning that we have no surds inside of our denominator. Most of the times when we rationalize our denominator, our question will look slightly different. So we will usually have something that looks more like this, where our denominator isn't just a surd, but a surd plus a whole number. So if we have, let's take 5 divided by the square root of 11 plus 1. And we have to rationalize the denominator. So we basically want for there to be no surds down here. So we need to come at this problem with a similar approach to the last one. So we need to think, what number a over a, or divided by itself, do we need to multiply this equation by? So 5 divided by the square root of 11 plus 1. What number do we need to multiply this by to get this, or to get rid of any surds inside of our denominator? One useful trick which you may remember here from quadratics is the equation x minus y multiplied by x plus y is equal to x squared minus y squared. And we also know that whenever you square a surd, you get a rational number. And we can see that in this case also both of the terms x and y are being squared, which means that if one of them were to be a surd, then we would no longer have any irrational numbers. So how can we apply this over here? We have our equation 5 divided by the square root of 11 plus 1, and we need to multiply this by some number a over a. So looking at this equation over here, we see that the square root of 11 plus 1 looks very similar to the x plus y, where 11 would be our x and 1 would be our y. So therefore, if we want to get it in this form, all we need to do is multiply the square root of 11 plus 1 by x minus y, where x is the square root of 11 once again. So the square root of 11 minus 1, and we need to put the same thing on top so that we don't change the value of our equation. So we get square root of 11 minus 1, and on top we have 5 times the square root of 11 minus 1, and in the denominator we have and once again we have to remember that it's okay to have irrational numbers in the numerator. They just can't be down here in the denominator. Another thing that you should note is that you won't always be directly asked to rationalize the denominator. Sometimes you'll simply be asked to simplify. You'll be asked to simplify your equation, and know that in your simplified version there can be no irrational numbers in the denominator. And what this essentially means is that when you're simplifying an equation, then you will have to rationalize the denominator as well. Okay, so just to help you solidify this concept, I'm going to be going over one more example. We have 1 plus the square root of 2 divided by 3 minus the square root of 2. So over here also we need to rationalize our denominator, and we'll do it basically the exact same way as we did before. We'll multiply it by some number a over a using the rule, or I used x and y last time, so x minus y times x plus y is equal to x squared minus y squared. So over here we see that 3 minus the square root of 2 looks like x minus y, so we need to multiply it by x plus y to get in this form. So 3 is equivalent to x, under square root of 2 is equivalent to y. So we multiply 1 plus the square root of 2 over 3 minus the square root of 2 by, so over here we want to get it in this form, so we multiply it by 3 plus the square root of 2. We want to make sure that our equation keeps the same value, so we have to keep it up, write the same thing up here as well. So from this we get 1 plus the square root of 2 times 3 plus the square root of 2 divided by, using this equation, we get 3 squared minus the square root of 2 squared, which is equal to the bottom first because that's easier. We get 9 minus 2, and on top we get 3 plus the square root of 2 plus 3 times the square root of 2 plus, let's make that longer, plus the square root of 2 times the square root of 2, which is equal to 2. So we get 5, bringing these two together, 5, and then bringing these two terms together, we get 4 root 2, so plus 4 root 2 over 7. And once again, we see that our denominator is rational as there are no surds in it. You should be careful to make sure that you don't take the square of the square root of 2 to be 4. We already know that this is equal to 2. A simple mistake that some people might make is they write it as 4, which is wrong. It is 2. So just be careful about that when you're solving. I've made that mistake multiple times. Anyway, thanks for watching the video, and I hoped it helped you understand this concept a little bit better. Actually, I take that back. I hope that you've mastered the concept. Okay, thanks. Bye.